So, first things first, who are you, what's your role, and where do you work?
Hi, Bart. First of all, thank you very much for having me on the podcast. I'm really excited to be with you here again. I really enjoyed the conversation last time. My name is Arshad Sayyad. I am the Chief Business Officer and a co-founder of StackGen. StackGen is a generative infrastructure platform company.
Very good. Now, what are three Kubernetes emerging tools that you are keeping an eye on?
I mean, the Kubernetes world is emerging and growing very rapidly. I think one of the things we're excited about is the scale at which Kubernetes has, proliferated across the enterprise. So there are lots of, fantastic open source tools that are being leveraged by the community. I think the one that we are really excited about is Crossplane because it really provides a wonderful abstraction layer for both the platform engineers and the developers to really amplify their impact within the value chain from a cloud deployment perspective. The other one that we've been watching for a while, which I think still has more runway to go through, is Backstage. But I think there are lots of similar platforms that are also emerging in the marketplace, like Cortex and others. But Backstage is the one that, from an internal developer portal perspective, is something that we are watching very closely because as more and more platform engineering teams come into the being, I think IDPs are going to become more important. But we still haven't seen the hockey stick kick in, if I may say so, for a tool like Backstage. But again, another tool that we use and we'd love to keep a watch on it.
One of our podcast guests, Brian, suggested the current infrastructure as code paradigm has reached diminishing returns. What new approaches do you think could revolutionize infrastructure management in Kubernetes?
Okay, so we all love infrastructure as code, right? I mean, it's I think penetrated the enterprise world quite rapidly over the last 7-8 years, whether it's Terraform, CloudFormation, whatever. I mean, there have been game changers, but in Kubernetes, things get complex very fast. We're starting to see the limitations. Think about this. You've got all these YAML files, and when you try to manage them with GitOps, figuring out the combined effect of all these configurations can be a nightmare, right? Plus, Kubernetes is so dynamic. People make changes outside of the CI/CD pipeline, and suddenly you've got a configuration drift. It's really a headache. So what can we do about it? I think we need to move towards more of an intelligent and adaptive systems world. And this is also our view from a StackGen perspective. We believe we are eventually going to move to an autonomous infrastructure kind of a world in the next 2 to 3 years. And here are some ideas around it. The first is declarative intent with policy engines, right? More and more policy compliance, risk compliance has to move to the left. So instead of writing scripts that say how to do something, we should just declare what we want the state to be. Tools like OPA or Kyverno can then enforce those policies automatically. In fact, Bart, even within our platform, we actually enforce all the risk compliance policies, over 300 policies automatically in the platform. Imagine saying all deployments must have resource limits, and the system just makes it happen. No more manual checking, and that would be really, really good. So that's one idea. The second idea, I mean, everybody's talking about AML these days for predictive scaling and self-healing. Kubernetes generates a ton of data, so why not use AI/ML to analyze that data and predict when we will need more resources? Or even better, let the system automatically adjust resources before we even notice a problem. I think we are a little bit away from that coming to be a reality, but I think we are heading in that direction pretty quick. Self-healing is going to be another one. If a pod crashes, the system should automatically know how to recover. And there are some emerging startups in that space as well. I think the third area, which a lot of companies have deployed, is service mesh integration, right? Service meshes like Istio and Linkerd are becoming essential for managing microservices. We should treat their configurations, things like routing, security policies, traffic management as code as well, right? This gives us better control and visibility. Now, the good thing about Kubernetes, another idea is it is designed to be extensible, right? We can create custom resource definitions, operators to automate application-specific tasks. So you've got a complex database deployment. You could build an operator to handle backups, failovers, and upgrades. And final thing is serverless architectures. Today, Bart, serverless architecture is on the edge of most enterprise architectures, but it's starting to sort of proliferate a little bit more. Tools like StackGen and Knative are taking things even further by abstracting away the underlying infrastructure. You should just focus on your functions and services, and the platform handles the rest. I mean, this can significantly reduce operational overhead. So I think these are some of the ideas, Bart.
Now, another podcast guest that we had, Angel, stressed that standardizing everything makes cluster management easier. What's your advice for building platforms that several teams can use in an organization?
This is an interesting topic. I think that there will always be two schools of thought. I think one school of thought would be standardization makes things more templatized, more slow, may not provide agility. Let me do what I want to do. Typically that's what most teams will think about as they're going through a growing pain. But standardization is definitely crucial when you're building a platform for multiple teams, right? I've always believed that standardization helps you gain more velocity if you have a multi-team environment working together. So you must make things consistent and manageable, and you also don't want to stifle innovation at the same time. It's a balancing act. So here are some ways to do that. One is could be hierarchical namespaces. Kubernetes namespaces are great for isolating teams, but they can become flat and hard to manage at scale. So having a hierarchy really helps you to create a hierarchy of namespaces. So you can delegate control to the teams while still maintaining some level of policy control at the top level. The second one, which we have implemented even in StackGen, is policy at code. Centralized policies are essential, but they shouldn't be a bottleneck. So tools like Gatekeeper, StackGen to define policies as code, but allows teams to request exceptions through a pull request process. Third, we talked about earlier, self-service portals are becoming more and more prevalent. I think using IDPs like Backstage or orchestration layers like Crossplane can help, reduce the burden on the platform team and empower the developers. Observability and cost management. I think everybody today recognizes the importance of monitoring and logging tools like Prometheus and Grafana. Make sure each team has access to the dashboards and alerts, and they are able to self-serve and keep control on the costs. It also provides the team with visibility into their resource usage, and so that they can optimize their applications. And the final thing, would be immutable infrastructure. Encourage teams to use containers and GitOps to deploy their applications, or use an automated value chain like StackGen to deploy and be more consistent and reduce configuration drift. I think one of the biggest challenges when we talk to CIOs, we find out is that configuration drift, especially between runtime cloud and what they think they have in cloud, is one of the biggest issues from a production support perspective, having production issues. So creating an immutable infrastructure is going to be important, and it needs to sort of be changed in place and not replaced all the time, right? So provide a guardrailed approach, but at least keep the innovation and agility going. So ultimately, you want to build a platform that's standardized and flexible to some extent, give the tools the autonomy, give the teams the tools and autonomy, but also provide guardrails and best practices to ensure stability and security.
You did mention GitOps there, and one of our guests, Hans, argues that GitOps is an excellent building block for building platforms with great developer experience. He mentioned the ability to merge, review, and discuss code changes in PRs, and the additional benefit of not granting permissions. Should all platforms use GitOps? And what's your experience here?
But GitOps is fantastic. We find ourselves that most of the clients that we are working with, they are starting to leverage GitOps significantly, both upstream and downstream as well. So we actually integrate with GitOps. It's fantastic. The ability to have an audit trail of all changes, to review and discuss those changes in PRs, and not to have to give everyone direct access to the cluster. Those are all huge wins. It definitely improves security and makes rollbacks more easier. But should every platform use it? Probably that's a more nuanced question. I mean, if I think about the pros, uh, GitOps provides great auditability, version control, and ease of rollbacks. And by using it as a single source of truth, you avoid giving developers direct access to the cluster. But the cons of that is not all infrastructure changes fit neatly into a Git workflow. What about emergencies, and you have a crisis situation, or you want a quick rollout to be done, or legacy systems that are not designed for GitOps? I think most enterprises between 2 to 15 billion would have about 30 to 40% of legacy. Organizations larger than that typically even have as much as 50-60% of legacy infrastructure. So that needs to be able to make change quickly and directly. So GitOps may not have or may not be the best approach. But again, it's a game changer for most cloud native workloads. It significantly reduces operational toil. But maybe I'll give some suggestions. Maybe three things come to my mind. One is hybridize the edge cases, right? Use features like Argo series kubectl apply hooks for those situations where you need to run imperative commands. This could be for legacy systems or ephemeral jobs or anything that doesn't fit the declarative model. The second thing would be around security hardening. GitOps doesn't automatically make your platform secure. You still need to harden it. So requires signed commits using tools like Cosign or set up automated drift detection with Argo series, comparison hooks, use SSO back pull request approvals. So that would be on this, the second suggestion. The third would be is probably avoid GitOps for critical emergencies, because in a true emergency, teams may not have the time for pull request, and I'm not saying break the process. Have a pre-approved break glass roles that can be used to make direct changes in critical situations. You could use Vault or a similar tool to manage temporary credentials for those roles. But overall, I think it does cut down operational work, in our experience by about 40% or more, especially in cloud native environments. But it does require a cultural shift. We think it's happening. We fully integrate into GitOps with StackGen. Teams just need to embrace the PR workflow, and that can save a ton of time and effort.
Now, in this, the paradigm of platform engineering, we're hearing more and more about thinking about platform as a product, and those who are building it are serving customers who are developers. How do you see this, particularly with the ideas of developer experience versus platform engineering? Are they one and the same? And what are the folks that are building these platforms thinking of this, platform as a product, and that they're there to serve? What are your thoughts on that?
I think this particular value chain is evolving quite a bit. What we are seeing, if we were to think about it empirically, Bart, we believe there are probably four types of customer profiles. The first one is, let's say, very large enterprises that are north of $15-20 billion roughly, where they have very large engineering teams. They have DevOps teams, and now they are putting in place, or they have already put in place, platform engineering teams, because for them, the development engineering talent and workforce is a critical enabler and a significant competitive advantage, where they want to be able to give them velocity, agility, self-service, clear the runway for them. So the platform engineering team focuses on more developer experience, because for them, the developers engineering talent is extremely valuable from a competitive edge in the marketplace. I think the second demographic would be firms between $2 to $15 billion that are still evolving. There may be 30, 40, 50% in the cloud, may not have all the tooling in place. So they typically have an engineering team and a DevOps team. Platform engineering is something that they're thinking about, but ideally they would like to automate and not have to invest, because they don't have the kind of dollars large companies have to spare on such initiatives. Then the companies below $2 billion, typically they tend to have more of an infrastructure, very thin team, not really very evolved from a DevOps or a platform perspective. They don't need to be, frankly, because they're using a lot of cloud platforms like Salesforce and NetSuite, etc. Not so much of custom application. And I think the fourth demographic is digital native companies that are growing really, really fast. They, in fact, want to leapfrog and not even want to invest in DevOps or platform engineering. They want to be in a no ops world, shift the power to the creator, which is the developer, and give an absolutely stellar developer experience where the developer is able to build, test, deploy in a matter of minutes. So we see these, four sort of demographics in the enterprise world, and platform engineering is really big in large organizations. It's probably more automated as you come to the mid market and the relatively medium to large enterprises, and digital native companies are trying to automate the entire value chain through tools and the latest and the best platforms that they can get their hand on, because they don't want to even invest in that. They're saying, look, can I just create a fully automated value chain for us?
What's next for you, Arshad?
Well, we are excited about the journey we are on. We are seeing tremendous growth with StackGen. We are scaling on multiple fronts. But I think two things I'd like to share from a market perspective, Part, right? One is more and more clients are multi-cloud, so they need a platform to be able to move workloads very quickly between different clouds, depending on either optionality, cost, agility or AI, infrastructure that's available. So I think that's going to become more and more true and bigger in terms of a use case. So I think that's really one. The second interesting one, Bart, that we're seeing is a lot of regionalization. Most countries are requiring data to be resident locally. So if you're actually a software or a SaaS platform provider, imagine if you have to keep your platform available in 8 or 10 or 16 regions. One of our large clients has to keep one of their platforms in 16 regions concurrently, available, harmonized, consistent across sometimes 2 or 3 different cloud providers, AWS, GCP, Azure. It's a nightmare when you think about regionalization. But fortunately, we, along with our customers, are able to automate most of that significantly. So that's another thing that's really something in the marketplace to watch out for, because I think it's going to become very much a need given the geopolitical environment that we operate in, and also the amount of data privacy laws that are emerging in every market. So I think as platform engineers, we all have to start thinking about that.
And if people want to get in touch with you, what's the best way to do that?
Well, people can email me at Arshad, Arshad at stackgen.com, or shoot me a message on LinkedIn or on Twitter, and I'm happy to connect with anybody. Thank you.
Fantastic. Arshad, thank you so much for your time today.
Thanks a lot, Bart. Have a good day. Bye.